recording. Okay. I don't know, but for the last few weeks, there's been a lot of like just a very few people. Normally, there's like 10 people, but this week and last week, it's very. Maybe it's because of the heat. I don't know. Anyways, so yeah, so this was the problem that we had, and I tried to like find an O of n solution, so in just one loop, but I couldn't do it. I was thinking of using maybe binary trees, but that still wouldn't do it because again we have like a billion, you know, the array can be of size a billion, so this is not gonna work. I found a solution online, to be honest. I haven't solved this myself, but I found this online, and this one is running in O(n) log of n. So it's a loop inside of a loop, but the one that's inside is not going step by step. It's going with a binary search, I think it's called. It basically divides the amount of space that you have to search into each time. And before explaining to you, I just want to Control V. Come on. Was it not working? Control C. Control V. Okay. Was this not working? Is it not working? What? Huh? I don't know what's happening, to be honest. It's okay. Very strange. A copy. Okay, it wasn't working for some reason. Yeah, so just to prove you that this thing is actually working before I try to explain it. Get something. So it is running, and it is running in 4 seconds. It's still like a lot, but it's you know, it's accepted, but it's still quite a lot. I couldn't find a way to make it faster, so maybe there isn't a way to make it faster. But I would like to, you know, if any of you can do it, I would like to see the way that you've done it. Okay, so how does this work? This is the example array that we're working on. Yeah. So first of all, again, we're getting an empty array, which is going to be the final results array that we pass. And then we're initializing a minimum like number, which is, okay, what I want to do is something like this. So for this array, I want to have an array that that is basically taking the lowest number to the right of it. So it's going to be something like this. I want to have something like this. Right? So we're going to start at 4. 4, it's going to be the smallest number, right? Because there's no number. 2 is going to be the smallest number. And then 5 has 2 to its right and has 4. So the smallest number until now is 2. And then it's going to be 1, and then it's going to be 1 for the 3. So this is the idea of it. To get the smallest number to the right, this is the idea of the min right number. So yeah, so here I'm just initializing an array of size n, and I'm taking the last number n minus 1 to be equal to the original array, to n minus 1, and then I'm looping through. Of size n minus 2, so I'm looping at the size of this one. So in this case, it's going to be 4 times. I want to stop the loop at -1. This is again Python. We usually use Ruby, but it's the same idea. So I'm starting at n minus 2. I'm stopping at 0, and I'm decreasing by 1 each time. And I'm saying the minimum right number at position I, so it's going to be at this position, is going to be equal to either itself or the one before it, if it's less than it. So for 4, there is nothing to its right, so it's just going to be itself.
Yeah.
For 2, it's going to be 2 because it's less than the
True.
previous one. For say 1, the previous one is going to be 2, but itself is going to be 1. So that's the idea of how I'm getting this array. Let's just yeah. And then this is the main loop. Here, again, I'm looping for each for each number here. So for I in a range of n, I'm getting the low and I'm getting the high, which is low is one, one further than the number I'm currently at. High is the highest number. So what's that? So if this is my array, we have 3, 1, 5, 2, and 4. If this is my array, I'm going to be looping from here to n minus 1 as a start. So this is going to be the low, this is going to be the high. And then I'm getting the answer, which is minus 1. By default, it's going to be minus 1 unless we change it later on. And I'm saying while low is not higher than the high, so while this pointer is less, like the position of the pointer is less than the high, so they can be equal. I'm still going to loop through that. I want to say that the mid is equal to the position of the high plus the low divided by 2. So this is like position 1. This is position 0, 1, 2, 3, 4. Plus 4 divide, 1 plus 4 is going to be 5. So if you divide by
5.
2, that's going to be, I believe, that's going to be 2. So I'm going to be taking this this guy over here, right? Because it's, I think when you divide in Python, it's just going to give you the lower number. It's going to give you an integer back. I'm saying if this number is less than my number, right? So now I'm comparing with this array that I created before. If this number here, the mid number, is less than my current number, then what I want to do, like I know for sure this is going to be one of the numbers, but maybe there's also another number to its right, which is going to be, which is also going to be smaller than it. So I'm saying that the answer is equal to the mid. So, this number over here, it could be a possible solution, but maybe there's also another to its right of it, which could be another solution. Yeah. So I'm saying that the low now is going to be this one. Right? I'm saying, okay, a possible solution is 2, but I also want to move. So in this case, again, I'm not looking at these numbers anymore because I know I have a solution, and now I have to look at the right of it. So I'm discarding all of this. So that's why it's log of n, the second part, because it's kind of a binary search. It's splitting the searching array each time by 2. So if I have a billion, the size of a billion, I'm not going through each item by itself. I'm going through a billion, and then through 500 million, and then 250 million, so on and so forth. So it's not of n, it's log of n. Yeah. In the case of, say, for example, 1, okay, we have this 1. Yeah. So again, we're gonna go from this number over here, right, to this number over here. Back my arrows again. And we're saying if this number, okay, yeah. So the middle of these two numbers is gonna be this number over here, and this number is of course greater than 1. So we're gonna move the high pointer to be equal to mid minus 1. So this high pointer is gonna be here. It's gonna be pointing to 2 as well, which means that for the next loop, the pointer is gonna be here. It's gonna be a 2, which is still bigger than the number that we're currently looking at. So the high pointer is gonna go here, And now we have the thing that breaks this inner loop, which is that the low pointer is higher than the high pointer, which just means that it's going to go out of the loop and it's going to give you the initial answer of -1. Yeah, and that's the algorithm that I found. Took me some time to figure this one out, but yeah, this one works. Yeah, it's very just like 3 people this week. A very low count, to be honest.
Oh,
I'm not sure. Maybe is it because we're using Python? I don't know. Uh, yeah, I think there isn't enough people to like go on or to try to solve anything else because like what's the point? Yeah. So for next week, I hope more people will be joining, and I want to go over dynamic programming, which is like a huge topic and it's quite used. Yeah. So I guess for next week we're gonna be going over dynamic programming, unless you guys want to do something else or solve some other problem.
um, no, I guess will just do it for next week. If maybe
What about you?
you can send me this link so that I can see the problem and.
This one, it's in the group. It's in the chat itself.
Oh, okay, okay, okay.
Yeah. So that's it. For next week, we're gonna be doing dynamic programming. I think we can just like just end it here because again, no people, so there's no point in doing anything else. Okay. I guess have a nice week and see you
Yeah,
next.
okay.
Take care.
Yeah.